Okay, I'm about to show you how to find out the limit of sine of x over x. But before I do that, I'm going to use this video to explain why this limit is so important. And then after this video, I will give you some exercises to do. And then after the exercises, then I will explain how you can find out the limit of this. In this video, why is this limit so important? Now, the whole point of us doing limits is that well, our aim is to understand calculus, but in order to understand calculus, we need to understand limits. Now, a small part of calculus is differentiation. That's when you our aim is to understand calculus. Okay, but in order to understand calculus, we need to be masters of limits. Um, but then within a small portion of calculus is going to be what's called differentiation, and that is when you find out the gradient of a function. So, for example, if you look at sine of x here, the gradient, well, roughly speaking, if you don't understand this, don't worry. The gradient is the gradient at this point here is, well, if you draw a what's called a tangent, a straight line at that point here. Let's say what's a gradient here? It's well, you draw a straight line here, and then you have to pretty much guess the gradient of this. Now let's say the point is right here. You can see that the gradient is shallower than it is here. So the gradient here is lower than the gradient at this point here. Now if you look at right here, you see the gradient right here will be well, it will be flat. So the gradient is 0. If you look at this point here, the gradient here is negative. It's negative, and when you get to this stage here, it's really steep. It's really steep, and then when you get to around here, then the gradient is still negative, but it's shallower, and then here the gradient will be 0. Okay, and then as you move around here, the gradient here, well, the whole point of calculus is, well, a part of calculus is to find out the gradient of a function. You see, we need to understand this, the limit of x hang on. We need to understand this here. We need to understand sine of x over x as x approaches 0. Now this is our aim here, and the reason why this is so important is that this here allows us to find out the gradient of this, and the gradient of sine of x is very important, very important. Um, you will need to find out the gradient of this if you want to do calculus. It's so important. Now, so our aim is to find out the limit of this as x approaches 0. Now, so when you look at the graph here, it will look like, so the limit of it, well, if you look at this function here, it will look like this. And then as x approaches 0, so you can see as from the right hand side, as x approaches 0 here, it's heading towards a limit. And then from the left hand side here, it's approaching that same limit. Okay, yes, from the graph we can see it's 1, but we need to do it algebraically. Okay, so but that on 0 is undefined, because if you put 0 into here, sine of x is 0, and then you've got if you put 0 into the x here, it would be 0 over 0. So we need to find out the limits of this as x approaches 0. Now, well, here's one way of trying to understand what's going on. If you look at x squared times sine of x here, it will look like this. Your sine of x will look like this. Okay, your sine of x will look like this. X squared will be something like this. Hang on, let me just draw an imaginary minus x squared. So when you have this function here, which is a combination of the two, your graph will look something like this. Okay, and here you can see that this function here is being forced by the x squared into 0. Okay, it's the wave here is being forced into the 0 here, and then it well, one way of trying to understand this here is to visualize this times this. Now look at this here. If you look at x to the power of 3 times sine of x, it will look something like this. Your sine of x graph will look something like this. Okay, and then your x to the power of 3 will look something like this. Now, when you combine the two, remember this point here is 1 multiplied by x to the power of 3. That would take you to here. This is 1 here, multiplied by x to the power of 3. That would take you to here, and so on here. And it just turns out that your, hang on, let me just draw a minus x to the power of 3. Oops. Hang on, bear with me. So when you combine the two, it will look something like this. Well, from the left-hand side, it's being forced into the 0. From the right-hand side, it's being forced into the 0 because of this x to the power of 3 term here. And then if you look at x, so now look at this here. So it's just x multiplied by this. So your sine of x will look something like this. And then y equals x will look something like this. Let me just draw a negative version in here. And when you combine the two, you see this point here is 1, it would be up here. This point here is 1, so we'll take the limit of this as x approaches 0. Well, from the left-hand side here, it's doing this. It's being forced towards the 0. From the right-hand side, it's also being forced towards the 0. Now, when it comes to this here, well, our aim is to find out the limit of this, but you can visualize this bit here as this times by this, because when this block here multiplies a fraction, it gets multiplied to the top. So this is what we're trying to understand. Well, we can rewrite this as a block times this block here. Okay, so now looking at this graph here, it would look like this. Your reciprocal graph will look like this, something like this. Okay. Okay, now let me just draw in the negative version. Hang on. And now, so what is the limit of this? Well, the limit of this is the same as you finding out the limit of this. So look at this. From the left-hand side, it would do something like this. It would get bigger and bigger and bigger, and then from the right-hand side, it will get bigger. Well, the thing is, because it's a reciprocal graph, you don't know where it's not being forced into the 0 like your x to the power of 3, x squared, x. You see all these terms here, they're forcing the sign into the 0. But then when it comes to 1 over x will look something like this. So where does it cross the y-axis? Because yes, hang on. Yes, out here it's getting smaller and smaller. But then it gets bigger and bigger as you go towards 0. You see, it will do something like this. But you see, where does it cross as x approaches 0? And it turns out that it crosses for some reason. So this here, hang on. This is like your, hang on. Let me try and your reciprocal graph will look something like this here. Okay, and oops. And then over here it will look something like this. This is your reciprocal graph here. And then the negative version would be something like this. Okay, and then the negative version here will look something like this. But then the sine graph here, as x approaches 0, you see, it's getting bigger and bigger. But where does it cross? Where does it cross as it approaches x equals 0? Well, first it crosses at 1, but we need to show that algebraically. Okay, so our aim is to find out the limit of this thing here as x approaches 0. But when you visualize this here, visualize it as 1 over x, and then times sine of x. And when, roughly speaking, when you sketch this inside your mind, it will look something like this: your reciprocal, and then your sine of x. So it will get bigger and bigger. But the thing is, you don't know where it crosses when x approaches 0. Well, from the graph we can see it crosses up at 1, but we need to show this algebraically. Okay, so in the next video I will give you some exercises to do before we try and understand this. Okay.